Everyone got pizza? Everyone good? We're about to start. Okay, good evening, everyone. Welcome to our first Tech Talk of the year. My name is Vicky Chen, VP Logistics from UTMist. Tonight's event is divided into two parts. The first one is a workshop conducted by Yang Chen, and the second part will be a career talk from industry professionals from AI company. A little bit about our guest speaker today. Yang Chen obtained his Ph.D. from University of Waterloo, and today he's going to share his insights on topic in natural language processing. So have your laptop ready, and ladies and gentlemen, please welcome Yang Chen.
Hey, this is the, oops, what happened? Oh, okay, cool. There's delay. Yeah. Okay, well, thanks everyone for coming. I see that there are quite a lot of people here. So I guess lots of people are interested in natural language processing. So what is natural language processing? I guess you might have heard of it. It's using computer to analyze, understand, and manipulate data, human language. Some example includes, like, say, translating between different languages by Google Translate. And I will give you more example in the next few slides. So natural language processing is actually a buzzword, is a key branch of the artificial intelligence these days and super popular. Just to give you how popular natural language processing is, here I provide two figures. Okay. So this one, yeah, sorry, it's a little bit small. Basically, it shows the revenue generated by natural language processing in the past few years. And then we can see that this purple color is the revenue in North America, while the blue one is the one in Asia. So we can see that actually the revenue explodes just in the past decades, basically. And then we can also see the same thing for the Google Train. So I guess you have heard of like Google Train, like what keyword is popular, like how frequent a keyword appears. And once again, we see that in just like since 2016, the train really just explodes. So, and these days, if you go for a job interview for data scientists, natural language processing is a must know. Basically, every company will ask you about natural language processing. So that's how important and how popular it is these days. And then here, I'm going to give you more examples about what natural language processing is about. So one basic task of NLP is text categorization. For instance, when Google get an email, then Google want to know whether it's a spam or not a spam. So it's a classification. And then we also have, say, Amazons have a lot of reviews, and then from those reviews, can you tell without looking at the star whether this is a happy customer or unhappy customer? So this is very important for the businesses. And then this example, the happy versus unhappy customer, is actually also a example of sentiment analysis. Basically, we have positive sentiment or negative sentiment. And some other example of sentiment analysis includes, say, given a tweet, is it a happy one or unhappy one? And these days, there are a lot of news in the social media. Given the news, is it a fake news or a real news? And this apparently is a very big deal. These days. And then the other basic task is concept entity extraction. For instance, given, like, say these days we read about some news about the tech hub in North America these days, including like Toronto, New York City, San Francisco, etc. And then there's like a lot of information in the article. Can you extract the name of a city out of the articles? or extracting names like the people's name from the article, which can be very useful to say, for instance, when these days company want to analyze the test, they want to mask the name to protect the PII, which is the personal identifier. I forgot the full name of it, but doesn't matter. But it's to protect the privacy of the customers. And then document summarization, for instance, given the article, can you tell what the topic of the article is? Does it talk about education, or does it talk about politics, or is it an article about movie? So the other basic task is relation modeling. So just to give you an example what relation modeling means. So let's say I have the relation of Toronto with Blue Jays. So the relation is that the city has this sport team. And then we see that a similar relation occurs if we talk about New York and Yankees. And then other example like Queen is a female while King is male, well, for instance. So these are some typical example of what natural language processings are doing. And this is just a very quick introduction about NLP. And then in the next few minutes, I will start doing a hands-on session. Before we get into that, does anyone have any questions? So it's super clear, I guess. Okay, so yes.
So NLP, like all the ones you mentioned, a lot of them have like a application text-based, text-based applications. But I assume NLP is like applies to language, like audio. If you take audio as input, it's the same. It's in the same brain.
Yes. So what people usually do is to first convert the audio into a text transcript, right? And this is also, a very, very good example of NLP, yes. And you can see it's actually a difficult task. And especially like if you want to understand how robots understand human speech, then they need to do this kind of task. That's a very good question. Any other questions?
Why do you say like natural language processing is a master norm if you want to find a data science job?
Why do I say that?
Yeah.
I went for an interview, everyone asked me NLP from my personal experience. And also, if you look at the job posting these days for data scientists, basically like NLP is like absolutely one of the bullet points. Okay. Any other questions? Yes? So your question, if I understand correctly, is there any algorithm that is very popular? Text. Right. Right. Oh, that's a good question. I think some popular sample tests include like Twitter. I'm sure, there are. I think lots of the researchers use like very typical Twitter data sets. Yeah, and then but there are more. Yeah, I think that one's the first one I can come up in mind. Yeah. Any other questions? Yes.
Just want to add that there's another data set called 20 News Group that maybe it's very popular data set.
Okay. Yes. Okay. Yeah. Thanks for sharing this 20 News Group. Right. And also, like these days on Kaggle, there are some data set. Like say, there's a data set that people try to where people try to use the news to predict the stock price, for instance. Yeah, so these are some typical examples. Thank you for your example. Any other questions? Okay, if no, then we are gonna move on to the hands-on session. How many of you have laptop? Okay, so for those who have a laptop, you can probably follow me with the experiment if you are interested. How do I switch? Sorry.
这就鼠标去哪？哎，应该就只能这样。这个谁说话呢？这什么？等会儿我看一下 chat。
Okay, so actually I provide a link of the notebook and then also the data set. So you can probably get the notebook and the data set through these two links.
这个有一些人说是网上的问题，但是算了，不会扰。
OK，
这个一会儿你可以看一下。no， 刚才的 Word 去哪里了？
Okay, while some of you are downloading the data and the notebook, I can answer the question from online. So the question is how to become an NLP developer from a software developer. I don't have a very good answer to this question because my background is not a software developer, but I'll say that some skill set that NLP developers should have includes mathematics and statistics, which are some fundamental skills for a data scientist. So if someone comes from a software developer background, then it's probably it's good to also learn a bit more math and statistics. I hope that answered the question. Okay, so yeah, so sorry. So this is the link. I think I had the link. So these are the first one is the link to the notebook. So if you click on it, and then you see text mining, and then click open in Colab, then you can actually run the code live. Okay, so for anyone has any issue opening the notebook with the link, just open the link and then open the notebook. So if you can open the notebook, please raise your hand so that I know how many people can do it. Okay, cool. So for those who have opened the link, then you can also download the data from this link. Which, well, this, to answer your question, like lots of the typical text data set can also be found on this website. So for instance, this particular data set is a data set of on the review of different drugs and medicines. So, and then after you click this one, just download the second link, which is drugs.com_raw.zip. And then you download it, and then if you use Colab, then you can upload what you just downloaded, unzip it, and then upload it to the same folder. Does that make sense? If anyone has any question, just raise your hand, then I can probably move around. Yes. Oh yeah. Okay, yeah, this. anyone succeed in downloading the data and then open a Colab page, which should look like the page on this background. So by clicking the first link and open the notebook and then click on Colab, you should be able to see this interface on the back. And then you download the data and then you upload it. And then upload the 2 data file. Does that make sense? Will anyone succeed in doing this? Oh, you are good? How about other people? Anyone else? Open this page and then upload the data to your own environment. Okay? Shall I continue? So please interrupt me if you need more time. I'll go through this hands-on session slowly, so that even if you are a little bit, even if you are still dealing with the data and the page, you can hopefully catch up. So, well, for like any other data science task, the popular language for the popular programming language for doing the NLP task is Python. And then there are a few very popular Python packages for doing this. So in particular, NLTK, called Natural Language Toolkit, is very popular. And then also, if we care about, say, text classification, then we probably want to do some classification problem, which means it's a machine learning problem. So we also use the sklearn. So these 2 are the main libraries we are going to use today. Okay, so the first part of the code, can everyone see it? Is it too small? I fear it's a little bit too small. Okay. But for those who can, okay, yes? Yep. For this one, how can you zoom in? Do you know? Like, does anyone? Yeah, this is not my computer, sorry. Oh. Okay, can you come in? Yeah. Zoom in. Okay, oh, cool. Okay. Awesome. Cool. Okay, so is it better now? Okay, so as I just mentioned, there are 2. Okay. Okay, cool. Okay, thank you. Yeah, because I don't really use Mac. Sorry about this. So yeah, as you can see, that these 2 are the main library. One is the sklearn, the other is NLTK. So a good thing about Jupyter Notebook is that you can run the code module by module. So for instance, if you run here, then you should be able to load all the libraries. And it shouldn't take too long. And then for those who doesn't have the environment set up properly, then these 4 lines will download the essential packages for you. Okay. So does anyone get any luck on running the first part of the code? You are good? How about the other? Good. Okay, so I guess other people can catch up, so I will move on to the next part of the code. So just to give you an overview of what we are going to do today. So today we are going to go through the entire pipeline of a very basic NLP project or NLP task, which is to categorize whether a drug review is a happy review or an unhappy review. Okay, so for instance, if someone said, "Oh, this is the best pill ever, it just cured me completely," then we can tell by our human brain that it's a good review. And then this is a terrible drug, then it's a bad review, right? Now the question is, how can we let the machine understand it and then do the categorization by itself? Okay, so and then just now we were trying to get the data, and then that's basically the step one for all the data science tasks. We need to obtain data. And then data can come from many sources. And here I just provide an open source data set. And then in your, say, in the future, if you are a data scientist, you might get data from, say, the company and other sources. And then let's see what the data set is like. Then we move on to the step of exploration. So this data set has two files. One is actually training data. The other is a test data. So if we use the pandas library, which is another very essential library for data science, then we can use pandas.read table to read the data. And then basically, this data actually have more than 4 columns. And in this case, we are interested in 4 columns, which is drug name, condition, review, and rating. So if we run this line, then we are going to see what the data look like. So this data set have the drug name, and the condition. Condition basically means that what is this drug for, and then the review. So you see that reviews are actually a long, it can be a short test, it can be a long test. And then in the end, for each review, we'll have a rating. So now the task is that now someone has a new review. Can we tell whether this person is happy or not? So rating 1 is the worst rating. Our rating 10 is the best rating. So let's read some of the worst review. For instance, oh, 9 is the best. Oh, no, here, actually 10 is the best. Okay. So for instance, some bad review includes, let's say, I was so depressed that I could barely even go out of the bed. I actually gained about 5 pounds. I guess this is probably a, yeah. So these are some negative effects. And then also say, worst burning last night. And some good reviews includes let's say it's worth the thickness sometimes for a healthier life. So this sounds happy. And then there are other very good reviews. So these are just some the overview of what this data set is like. So now for the review, we see that there are some special characters such as this. And this one is actually the prime, right? But for some reason, it show up to be this symbols. And for instance, I have, right? And then it is. So then, the next task we are gonna do is to clean the test to make it look nicer. So using Python, it's easy to achieve this task. So basically, what we are gonna do is that we extract a review column, and then there are also, we notice that there are also the quotes at the beginning and the end of the review. So we strip the review. We strip the quotes, and then we replace this symbol by the prime. And then after that, for instance, I have, for instance, there are like it is, it's, and then for the analysis in later, then we can replace it's by it is. And then, you know, you can, after reading the test more, you can figure out what you want to replace and what you want to change.
Can you explain more like how they define the best review before you do the
Okay, how to define a bad review and a good review?
You're saying like the worst review rating,
Right.
how it defines and
By define, you mean like how does this review? Oh, sorry. Right.
And that's the first one, like how the process, like how it defines.
How do the question is how do you know whether review is a bad review or a good review, right? From the data set.
Right.
So okay, to answer the question, the data set itself have one column called rating. So when this data set is taken, we already know that there's a label, whether a review is score 1 or score 2 or score 3, score 4 or score 9, right? And then so it's like, say if you take some review from Amazon, right? Then you can already see how many star it has, right? That's right. It's already given, right? But then what we are interested in is that now, given a new review, we don't, like, without star, can we actually tell what is a star? Whether it's a happy one or unhappy one. Yeah. Thanks for the question. Sorry I didn't explain it very well. Any other questions? Does that make sense? Everyone knows what we are going to do now. And then for those who have the notebook, you just need to click the run button. Then you are going to be able to run the notebook. Okay, so the button is here. Or you can click Control Enter if you know Jupyter Notebook well. Okay, any other questions? So continue with the text cleaning, right? So text cleaning is an art. There's no standard on how you are going to clean the text. So it really depends on what your purpose is gonna. What is your purpose for your job, right? So continue like say IN. I can if I want to make it cleaner. I want to recover the full form of IN. Then I can replace IN by IN. And then, so these can be easily done through Python. And I just give you a quick example here. But probably if you dive into this data set more, then you will figure out, oh, maybe I need to clean it more. And then you can add more stuff. For instance, right here, we see 12 years, doesn't have space, right? So we can definitely just say replace right? Replace 12 years by 12 years with the space. But then sometimes you may say that, oh, so I noticed that there are other instances where a number is followed by words but without a space. Then you probably want some other tool called regular expression. And yes,
I see how for it's you're replacing it with itis. So shouldn't it work once for the entire dataset? Why are you continuously telling it to replace it? If there are many instances that there is this that this is the error, so you have to write that many times. Wouldn't it work just only once?
Oh, actually, yeah. Yes, you only need once. So yeah, sorry, I was in this case you only need once, but you notice that I actually do it twice because this one I start with a lowercase and this one I start with a capital. Right, so it's slightly different, but then there are smarter way of writing this. Here I just give you one example, right? For instance, you can always say sometimes it doesn't really matter whether the for your task in this case it doesn't really matter whether your test is the uppercase or lowercase. Then you can always convert the string all the tests to a lowercase and then followed by other cleaning, right? So if we define this is the rule of cleaning our test, then let's run this again and see the same best review and the worst review. Then I notice that since I add the lowercase, right, then all the tests become lowercase, right? Even I become a lowercase, right? And we see that now every this symbol. Oh, sorry. Oh yeah, this symbol, right? All these symbols become the prime, right? For instance, I am, right? So we notice that here I am still I am, but not rather than I am, right? That's because here I put a uppercase. And you can always play with your code. And then now we notice that all the I am, right, become I am, right? So, and then again, cleaning a test is art. So it really depends on what kind of tasks you are doing. And then eventually, remember, our goal is to build a good classification model, right? And then probably after building a model, you notice that, oh, so what is the reason that my algorithm is not doing a good job? Then probably I need to go back to this step, cleaning the test, and then see, maybe it's because, say, there are some cases say I do not or I don't, right? And then somehow machine does not realize, oh, I don't, that not is a negation. So then maybe I should replace don't by do not, right? Things like that. So you really have to iterate, and then eventually probably it's gonna take a lot of time. And in practice, I can tell you that the step of text cleaning can take you 99% of the time, and then you only spend 1% of the time just doing building a model. So being a data scientist is not really about building machine learning model, but most of the time about text cleaning and pre-processing. Okay. Like
if you have a large data set, it will be are they autocorrect and all from MS Office or just Python?
Like any standard library of doing this? Yeah. No. So well, to answer the question, basically you use pandas, and then you also use say NLTK, which help you clean the test. And then there are also some other libraries, but there's no standard pipeline. And again, the reason is that, say in some case I might want to keep its, and in some other case, in some other task, I might want to convert it as it is, right? So nothing is standard. But then I can tell you that the library people commonly use are pandas, NLTK. Yeah, these are which are the library I call at the beginning of the code. Does that answer your question? Cool. Any other questions? Yes?
How do you calculate spelling mistakes that people might make in use, or spacing errors? How do you cover all
all of those in a large data set?
That's a very good question. So it's very difficult task, actually, I can tell you. So the spelling mistake, I think there's a library in Python doing like some basic spell check. But then, but I will say that what I would do, also it depends on what kind of data set you have, right? For instance, here the data set is a drug data set. So probably the misspelling, we will have a dictionary of what is the common misspelling of the drugs are and what are the correct spelling. And then you build a dictionary. And then you can use Python. I think Python has like say string.replace. Then you can build a dictionary, say, let's say weight. Let's assume this is a misspelling, okay? Let's say it's actually talking about height rather than weight, right? Oops. It's probably replaced. Oh, it's just, okay, sorry. How do I move? I really hate my math. Let's say if I give another example, right? Let's say this is a misspelling, okay? This one is a misspelling, that's it, right? So you can always build a, so what people usually do is that you build a dictionary. So I believe, what is the column name of this? Condition, right? Right, let's say this is a misspelling, and then the right spelling is called something. And then Python can always do this kind of task. So now you build a dictionary that map the wrong spelling to the right spelling. And then now you do the replacement, and then you should be able to see that, oh, now it's become something, right? And then really, it depends on what data set you have. And each data set will have its own misspelling, typical type of misspelling, and then you build a dictionary and then do this kind of replacement. That's I would say that's the usual way of doing it. But it's a very difficult task in general. So I would say it's still a research topic. And Google, I'm sure like places like Google are still trying to figure out how to do this. Other questions? And here, here I'm just giving you a taste of what you can do. But in practice, probably like say big company like Google, they have a very sophisticated tool of doing this. And then the next thing we are going to do is that instead of predicting the score, which is from 1 to 9, it's actually a very difficult task because sometimes it's kind of blurry. Say someone thinks 6 is a pretty good score. Someone will say 7 is a very bad score, right? So then to make it, to take this into account, how about we just say any rating that is below 6 are considered bad rating, while anyone that is above 6 is considered good rating, right? So then what we do is that we choose a cutoff score, which is say 6, right? And then and then usually for the classification task, we have an input which we call X, And then in this case, the input is a review, right? And then we want to predict the output, which is the rating, right? But then to make the rating binary, then what we do is that we say any rating that is below the cutoff, 6, is let's call it bad, right? And then we call it 1. And then any rating that is above 6 is considered as good rating, which we call it 0. And then now we make it a binary classification problem. Okay, so this is what we do here. And then we do, we apply this creating label, creating the label of happy or unhappy, which is 0 or 1, to both the training set and the test set, right? And now we see that for this particular data set, there are 20,000, about 21,000 good ratings, while there are also like 10,000 bad ratings. Okay, so it's still kind of balanced data set. Okay, so now to do, and then so for machine learning tasks, we know that usually we input a matrix and then output a vector, which represent the data set. Does everyone have the concept about this? So for a machine learning task such as regression or classification, your input X is a matrix. Your output Y is a vector of like 0, 1, 0, 1, 0, 1 in this case, right? So now the question is, our inputs are tests. How do we use the machine learning tool to do the prediction? We have to first convert these tests into a matrix, right? So how do you do this? Anyone has any idea like how you can achieve this? Any proposal? Sorry?
Term frequency.
Yes, well, I guess you already know it, but what is term frequency? What is term frequency?
Term frequency is the count of the count of the different words in the text.
That's right. Okay. So, well, I guess you already know it, but here, just to elaborate your answer, yes, one very simple idea of converting a test into a matrix is that we count the number of the words appear, we count the frequency of the words appear in each review, right? So to be more explicit, here I consider just one example where I take 5 of the reviews out of all the reviews, okay? And these 5 reviews are all about a medicine called Paxil. Yeah, I actually don't know what that is, but it's a pill. And then it's actually, from these reviews, we see that it's actually related to, it's actually an antidepressant pill, okay? And then, so now it's like, okay, we are given a bunch of tests, how do we convert it into a matrix? So what we can do is that we count, okay, in the first test, this word appear once, this word is appear once, the appear once, and then best appear once. So we can actually construct a matrix. Let me first run this part. Oh, so we can actually construct this where I say is appear once in this review, then sorry. How can I drag this to the right? Oh yeah, okay, cool. So you see that you kind of like create a matrix where say in this test, 2 appear once. So then we put a 1 here, and then is. In this test appear twice. Then we put a 2 here, right? So let's go back to the first if appear once, right? So if we go back to the original test, then let's verify this. So the original test is right. So if appear once, right? So we put a count 1 under if, and then it appear, oh sorry, is, right? Is appear twice. So we put the count 2 under the column, which is. And then, so this is the way that we can actually construct a matrix. Do you see that? Do you see this idea? And this way of constructing matrix is actually called count vectorizer, which literally means you're counting a word appear how many times in this review, and then you just say in this row of the matrix, then you add you put the entry as the count. Sorry, you have a question?
So the rows represent what again? When you feed the network and input, is it one review at a time? And if so, then what would the rows be? Sentences? Yeah, is that the case?
The row is a review, which can have many sentences, right?
Okay, so you just feed it, like is one input like a 1 by however many words? Like is it a 1 row?
1 row is 1 review, 1 input. Yes, exactly. Actually, if this is a bit too difficult to see, let me give a simpler example. How many minutes do I still have? I guess I'm running out of time, right? Sorry about that. So then let me use the blackboard to give a very quick example. Okay, so let's say I have 2 reviews, right? Then I can construct a matrix of 2 rows from these 2 reviews. So we first construct the dictionary, it's, right? And is, great. These are the dictionary that we use in our contest, right? I like, and then it's is already part of the dictionary, and then sucks, right? So now we do the counting. So it appeared twice for the first review, right? So for the first review. And then is appear once, great appear once, I appear once, like appear once, sucks appear 0 times. For the second review, only it, sucks, and then everything else appears 0 times. So this is how you actually convert the test into a matrix. Does that make sense? And then, so this is a very basic idea. So once you have the matrix that represent your test by this counting, which is called term frequency, and then you also have the label, which is 1 and 0, representing happy or unhappy, then you can do a typical machine learning task. So how many of you are familiar with machine learning and the classification? Okay, so I guess not many, but here's the magic. So once I convert the test into the matrix, and then I have the label, which is happy or unhappy, then I can train some magic model. And then, so let's wait, right? So now machine is learning the model and then see whether, you know, and after this learning process, then learning through all the data, the machine can tell whether a review is a happy review or an unhappy review, right? So for those who know machine learning, you probably know that it's training a model is going to take a long time, and depending on how many data you have. Okay, so here the training is done, and actually here using a data set, it shows that the accuracy of the testing is about 80%, which is not a very precise model, but it's better than 50%. It's better than just random guess. Okay, so now let's say I have three review. I want to tell whether they are happy or not, right? So given these 3 reviews, this is a great drug. I don't like this drug. I do not recommend this drug, right? So so now after building this model, I let the machine to tell whether they are happy review or unhappy review. So the machine tell me that the first review is good, the second review is bad, the third review is good. Okay, so we see that our model is not the best model. It makes some mistake. And then if you really want to know whether, so you see that the whole data science project is like this. You first, if you only spend a little bit time build some very rough model, then you're likely to get something, but something not particularly precise, right? So then the next question is that, how can I improve my model such that in the future, when this kind of review is given, then you can actually tell it's a bad review, right? So probably one of the possible reasons here is that you see that probably the machine learns that don't is something bad, while do not is the machine cannot tell it properly. So probably if you can go, you might need to go back to the text pre-processing, the text cleaning part, right? To be more careful about the negation. And the other thing you can do is that instead of just counting one word by one words, you might want to count like 2 words as well, right? You also want to count, oh, is great or like it. You know, you put 2 words as a unit. And then you reconstruct your matrix, X, and then you feed it into the model. Or you can try some other model, right? Instead of only using I'm just using logistic regression, which is the simplest model for doing the classification. But for people who know the model, you know that, who know machine learning, you might know that logistic regression is a very rough model, and you might want to use something else, such as random forest, to do it. Okay, and then you have to try it many times, and then this is the art and the fun of data science. Okay, I think that's it for my hands-on session.
Any questions for Young Chen before we move on to our next session?
Any questions? Oh, okay. Okay. So yeah, I see some online question here. So let me start from the bottom. How does this compare to RStudio and its algorithms? So basically, it's a comparison between Python and R. So I'll say that both are very popular language for machine learning and like natural language processing. Personally, I use Python, so I'll say Python is more powerful. But for people who are expert in R, I'm sure that they will say, you know, R is also really good. So it really depends on which language you are more familiar with. And then, do you need to get all the words in the documents? What if there are new words in the test set? This is a very good question. So what you can do is that there are some approach people use when there are new words in the test set. One very simple idea is that you just ignore those new words when you construct the matrix for the test set. Okay, but then there are more sophisticated techniques, such as when you are constructing the matrix for the training set, you might already kind of take into consideration what new words could possibly emerge in your test set. And then you enlarge your dictionary while you are building your training matrix. Okay, I hope this answered your question. Any other question from the online, from the audience here?
How large a training set would you need?
Usually, the larger your training set is, usually the more likely you are going to get an accurate model, because you are less likely to okay, yeah, because like with more data, then you are less likely to overfit. Yeah. So, but then the accuracy does not only depend on the size of the data set. It depends on many other things, like which model you choose, how, and in particular, how well you pre-clean your data. Other questions? Yes?
So I see there's something called stop words, right?
Yes.
So no, not, never.
Right.
And in the past case, you have one I do not recommend.
Right.
So is there some mechanism that you can sort of recognize the stop word and make it a sort of like negative coefficient into the training, so it knows not recommend means actually the negative of recommend. So I could improve the accuracy.
Yes. So one thing you can do is that instead of only while you all use each word to build a matrix, you also take into consideration of the combination of two words, right? So this way, using this approach, you can take into negation into consideration. And then stop words is usually defined by the linguistics. So there's actually a dictionary of the common stop words in English. And usually, because what does stop word mean, right? The, say, the, and this kind of words, they don't really carry any substantial meaning. So usually these words are removed from the your analysis, right? Because you are adding noise to your model, to your data. So usually what people do is to remove these so-called stop words before doing the analysis. And then the stop words are really built by the linguistics. And then like there's actually a standard, well, not standard, but there is a commonly used stop word dictionary in English, for instance. Other questions? Yes?
Would this model be applicable to different languages?
Yeah, yes. I think so. I don't have experience of doing this for the other language, but then I will assume that for the other language, you can do similar things. And there are more sophisticated techniques, such as these days, if you heard of the neural network, recurrent neural network, is usually achieve much higher accuracy than, say, just the simple word counting. But then probably, if you are interested, you can learn more math and then take, you know, dive yourself into this. It's very interesting.
Well, thank you so much. And on behalf of UTMist, I would like to present a small gift.
Oh, thank you.
Thank you.
Okay, well, I hope you guys get something out of this. Yeah, sorry it was a little bit disorganized this time, but hope you enjoy the talk. And then so for anyone who, well, I mean, you can see my GitHub, so you know who I am, and just feel free to reach out to me. And unfortunately, I can't stay here for longer, but hope you enjoy the rest of the session. I guess, oh, sorry.
Yeah, let's welcome our next speaker from MangoTech.
So I guess let's have a short break first, and maybe we will continue with the next section in 5 minutes. And anyone haven't got the dinner yet, feel free to come over and get some pizza and drinks. So we will begin the next section at 8:15. 把这幕又选这个。 of the titles and positions pop up, such as a data analyst, business analyst, data scientist. So for the first type, the data analyst and the business analyst, they may have already existed for a long time maybe before data science and machine learning, those words pop up. So what does a data analyst and the business analyst do in a big company? If there are also other type of positions also exist in the company, then data analysts and business analysts, they are usually doing more kind of fundamental jobs with data processing and getting the insights from the data. So they may be the positions that getting know more about what data it contains, what kind of information contains in a data set, and what type of data we have in the database. So there are more domain knowledge related with these type of positions. And then followed by the data scientist and the research scientist. So these are the positions that playing more related with the modeling and the solution providing. So usually they work with type of business and solve their problems with data-related models. It is not necessarily to be a machine learning or deep learning model. It can be some statistical modeling or any of the data-related models, but they need to know about different type of models and choose the best one to tackle this question. And so for the research scientists in particular, it may have a higher requirements about like your educational background, because it is more the work of a research scientist, maybe more like innovational, and you need to develop deeper knowledge about a specific domain. So and then followed by the data engineer and machine learning engineer. So typically, data engineer use the big data tools such as the Spark or Hadoop to deal with the large scale data sets. So usually it means that when the data set is kind of million size or trillion size, the traditional way of processing the data is not working well. So you need to use some like distributed systems and big data platforms, ecosystems to process those data processing steps. And data engineers build up that type of data pipelines to deal with that. And another type of engineer position, the machine learning engineer, I think it just come up very recently. And what does a machine learning engineer do is usually a machine learning model, instead of using it as a one-time conception, the machine learning engineers built the machine learning model into a product that can be reusable by multiple users, or it can be run scheduled for a long time. So the machine learning engineer basically working together with the data scientist and the software engineer, doing as a bridge to connect the modeling and the development together. So I will elaborate a little bit more in the following sections. And the next question, what is the daily work like as a data scientist and machine learning engineer? Firstly, from the project's perspective, what type of machine learning problems that will IT industry and finance industry work with? So there is no like very much difference, like some type of projects that only IT companies will do, but based on the specialties and the characteristics of different domains, there are some common type of projects in each industry. For example, in an IT industry, it is not very common of the case like the machine learning works as a very core function in a software, because especially for an IT startup, they may already have a software already, and they may use the machine learning or the deep learning as analytics tools. So it may be very common that machine learning are applied in such as the customer clustering and the marketing campaign to help them to analyze the market and foster the sales. And also the recommendation system is also a very common type of projects in the IT industry, such as the e-commerce companies as Amazon or Netflix. They analyze the historical reports of their users and recommend their provide the similar products to their customers. And regarding to the financial industry, based on the characteristics of the data, so in financial industry, the data is more like time series related. So there may be more prediction or forecasting in the financial industry, such as the stock price forecasting and the risk index related forecasting. And a very common, a very mature project is about the predict score prediction based on the user's profile. And also fraud detection is a very major aspect in the financial industry with the use of machine learning techniques. And then I will briefly talking about what is a typical day as a data scientist and a machine learning engineer. So firstly, as a data scientist, I feel it's more like a consultant role, because you will work with a particular type of business problems. And firstly, you will talking with the clients to understand what is their problems, what problem they want to solve, and then to gather the information and the data to see how you can help the client to solve these problems. And then you may do a lot of data collection to go to different departments to ask about what type of data you can get and how you can get it. And then do some pre-processing and modeling and feature engineering together with the data analysts, because they may know these type of data better and they have more domain knowledge. And then you build some, do some feature engineering and choose from different type of models and do some parameter training, model comparison, validation, and got results prediction. And then you will present your results with the clients and to get some feedback and digest the feedback and repeat the process until like the clients accept your results. And you need sometimes it's a very interesting thing to integrate your method to the business clients, because they may not very familiar with data science or deep learning. So it's a very interesting thing to balance your modeling and the interpretability of the models. So there is a case like you use some very advanced and very high-level architecture about the of a deep learning model, but the business person may just take it as a black box. And you cannot just say like the model gives out this result, and the business people will say like how to interpret this, why it gives me this result. So you need to have a good story about the result, about how you get this. So this is typically what a data scientist do in a daily work. So it's not like a consultant. You need very good communication and a very good storytelling abilities. And next part, from a more engineering side, if you do a more engineering related roles, probably you will work in an agile style, work style. So it is more like a paradigm. If you are working in an IT industry, you may not you may have heard about the agile style. So usually it is working as a squad, which consists of different roles, including data scientist and a machine learning engineer and a PM, which is the product owner or the project management. And you may not come from the same department, but you work on the same project. So each person takes its own roles and contributes their responsibilities to a project. And you will have a daily stand-up every day, yeah, to talk about what you have done yesterday and what you are going to do today, and is there anything stuck your work. So as a machine learning engineer, as I said, it is a bridge between the software engineer and the machine learning data scientist or the machine learning modeler. So basically, these two sides, they work with different technical stack. Like software engineer, they may be more familiar with Java or Scala, those programming languages. And data scientists will more likely to use Python or R to build models. So you need to deploy to save the model as a certain object that both of the sides can take this object and transfer this smoothly. So this is what a machine learning engineer will do in a daily work. About the next section, we can have a look at what are the requirements for the candidates in different industries and different roles. So basically, from the educational background, I would say that tech companies will prefer the CS or engineering background, but any of the quantitative majors are also preferred. But in finance and banking company, if you're doing data-related works, then firstly you need to know about how to code and how to program, and some quantitative measures are also preferred, and financial knowledge will be a plus. And what type of skills are preferred and what level of coding is required. For the technical companies, some of the machine learning related roles, they are basically just software engineer roles, but they may be working on a machine learning project. So their requirements is the same as the software engineers. So if you are familiar with lead code, then in the tech company, the machine learning related roles is kind of the medium level to the hard level in lead code. And they're basically hiring a software engineer who has a knowledge of machine learning. And in the financial banking, the coding level is much more lower or easier. Like if you're using lead codes as a reference, then maybe it's the easy to medium level. I haven't seen any like algorithm questions higher than the medium level. And also from the technical stack, like the if you're doing machine learning and data science, the SQL and the Python is a must. And then in banking or finance, maybe they also use R and the SAS, and also data visualization tools. And in tech company, you may also know programming languages such as Java or C, and also familiar with the command lines and the Bash language and the big data tools. So in the next page, let's have a look at the career path. So generally, there are two career paths. One is the more technical path. One is more related to the management path. So in a typical tech startup company, the technical path would be from junior to senior, and a lead of a group, and then the architect. And management path is like the similar at the beginning, and then change to a project owner or project manager, and then maybe a vice president and the C-level positions. There's no limits, right? And in the finance industry, Basically it's the same, but typically the big companies have more levels, so they maybe have more intermediate positions. And the one thing in common is the higher level you are, the less hands-on work you will have. So basically the management roles will look at the more bigger picture of a project and doing more like the people management related works. And the next one about the learning paths of the data science area. These are the list of the items that I think that may be related with the data science area. So first and foremost is the statistical and the math foundations, which is like a must for the following studies. And then is the machine learning and deep learning algorithms. So many of you may ask, how much should I learn? What level should I learn about the algorithms? I would say like, as you have seen in the previous workshop, like loading a model is not a difficult thing. You can choose a proper, a suitable library and just load the model as a function and use it. But how much you should know about the algorithms? I would say in an interview, you need to at least explain a model from scratch. You don't need to code and implement the whole model, but you need to at least explain what the model is about and what's the background logic about model and what is the advantage and disadvantage about model. And for a particular type of questions, what type of model you will choose and why you choose it. So these are the type of the degree that you need to learn about machine learning and deep learning models. And then is the data wrangling, processing, cleaning, and visualization. As you see from Young's presentation, like there are a lot of work related with data processing that even takes more time than you modeling. And also since you're working on in a real problem to solve it using machine learning as a tools, so you need to have a business acumen and also know about the case study. So that typically gave you a business sense about how to transfer a problem to mathematical problems and how to deliver the values and the solutions. And then the following three are the more engineering related items. The big data ecosystems, which is related with Spark and Hadoop and Scala. And the data streaming is one part of the big data pipelines. And also some DevOps and automation tools. So that basically means when you build a machine learning pipeline, you can use some automation tools to connect the different steps together and schedule it and monitoring, set up some monitors to monitoring it. And also deploy the model into a production environment that this kind of model can be used and can be called by the users. So that is also a very important part. Instead of building the machine learning model as a one-time solution, there is a more and more increasing trend of using the machine learning as a product. So last but not least, maybe the most exciting part is about the salaries in the data science area. I would say like this statistics from the 2019 July is pretty fair. Like it's kind of the standard salary for a data scientist and a machine learning engineer in the industry. So as an entry-level data scientist is pretty about 80-ish thousand. And of course, the United States has a much higher level of salary compared with Canada. And for machine learning engineer, usually you need to gain some experience before getting a machine learning engineer position, because it requires both of the development experience and the machine learning experience. So these are the information I can share with you. And we have two guests from the data science area as well. We have Joyce, who works as a data analyst in a consulting company. And we have Vincent, who works as a data scientist in Scotiabank. So the following section is the free networking part that you can reach out to them and ask the questions that you are interested in. So, and also take some food and drinks back home as much as you want. And thank you for listening to the talk.
Now, if you guys have any questions, feel free to come down and ask the people from the tech industry.